Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about how to use the MCMC algorithm or the Markov Chain Monte Carlo simulation method for multiple imputation of missing values. Even before I proceed to demonstrate how to use the MCMC algorithm for missing value imputation, may I request you to subscribe to my channel, also like and share my videos. Let me begin by introducing to my audience the data set that I'll be working on. This data set is called as the telecom data set. This data set is present in the samples folder of SPSS. There are approximately 10 variables in this particular data set, beginning with variables like tenure, age, marital status, address, income, and education level. Primarily, you have demographic details of the customer. The last three variables here are years with the current employer. You have whether a customer has retired or not. The last variable that you have is gender. As you can see here, there are a lot of null cases in this data set. Typically, whenever there are blank cases in a column, we use the mean imputation or median imputation method. However, there are many cases which could be more complicated, and therefore a mean imputation would not suffice. What is the alternative when you have patterns in the data set? Here is where I'd like to take a moment to explain the meaning of the word pattern in this context. When we say pattern, we are referring to groups of cases. Let us say in this data, you may have 10% of the customers who have not given you information about income as well as their tenure. So these are people who have not given you information about two variables. Similarly, you may have the second pattern wherein people have not given you information about years with the current employer, whether they are working or retired, and their income level. This would be pattern number 2. Like this, there may be different combinations of variables for which we may have blank records. As you can see in this data set, let me apply a Excel filter. Let me do this again. With this filter, I am going to select all the null cases for income. Let me remove select all, scroll down and select only the null cases. You can see here income has a lot of null cases. I'm trying to explain what is the meaning of pattern. We are not just interested in income, we are interested to check whether people have given missing values for other columns along with income. So I will move on to years with the current employer, remove select all, and select only null cases. You can see here, there are a lot of customers who have not given you information on income, years with the current employer, and address. Similarly, you can see for the column retire, you have a lot of null cases. Let me apply one more level of filter and select only the null cases. You can see here, there are at least 15 records here who have not given you information about address, income, years with the current employer, and whether or not he has retired. Like this, we may have many combinations of variables for which you may have several null cases. Since this is a simple illustration, I have applied a Excel filter. Imagine if you have 40,000 records with 40 columns, you can't go on applying Excel filter because there may be hundreds of such patterns that are present in the dataset. Hence, manually to check the combination of these variables might not serve us well. This is where SPSS multiple imputation helps us. This is a two-step procedure wherein in the first step, we will be checking for the presence of missing values in multiple variables. And in the second step, we will be using MCMC algorithm in combination with Bayesian inference to impute for missing data. Let me remove the filter. I will now proceed to SPSS. As you can see here, this is a blank screen. This is a blank screen because I have not yet loaded the dataset. Let me go ahead and load the dataset. To load any dataset, you have to go to the File menu. In the File menu, I will move to Recently Used Data. SPSS displays 10 recently used files. I will select the very first file, which is called as telco_missing. Let me select this particular file. Once I select this file, you can see the data set is loaded. You can see here there are a lot of blank entries. What is the sample size in this data? I have a healthy data set of 1000 records. So this is a good data set with a healthy sample size. The first thing that I'd like to do is to check whether there are any patterns in the data set. To check if there are any patterns in the data set, what you need to do is go to the Analyze menu bar. You have different options. I will select multiple imputation. I repeat, please go to the Analyze menu bar and look for the option multiple imputation. There are two options that are present here. The first is called as Analyze patterns in the dataset. The second is called as Impute missing data values. I will go ahead and select Analyze patterns. Once I select Analyze patterns, you can see a new dialog box which is called as Analyze patterns dialog box is displayed. I'm going to select all the variables and push this into, let me do this again. I'm going to select all the variables and push this under the Analyze across variables. I have a note of caution. The variable level of education is a problematic variable. Therefore, I'm going to remove this from the analysis. If you have any variable which you want to use as the weight variable, you can go ahead and specify the weight. Just by selecting the variables, you will be able to analyze the patterns. I'd like to draw your attention to three default options that are present in the output. First is summary of missing values. As the name itself suggests, this will give me a summary table of the missing values. The second is to obtain the patterns of missing values. The third one is display variables with the highest frequency of missing values. What does this do? Out of all the variables, the third option will display the frequency of those variables with the largest percentage of missing cases. I'm happy with these options. Let me draw your attention to an important point here, which says minimum percentage of missing for the variable to be displayed, that is 10, which means only those variables which have greater than 10% of missing cases will be displayed. This is entirely under your control. You can change this to 5 or 3%. You can also choose any number based on your requirement. We are all set to analyze the patterns in the missing data. Let me go ahead and hit the OK button. Right now, we are in the output window. As you can see here, the very first chart that you see under the missing values is a pie chart. You can see the overall summary of missing values, and there are 3 pie charts that the algorithm displays. The very first chart is for variables. As you can see here, the red color displays incomplete data. The blue showcases complete data. There are 8 variables, and each of these 8 variables has missing records. Let's look at the second pie chart, which is showing you the distribution of complete and incomplete data at the case level or the record level. As you can see here, approximately 50% of the cases are missing. If you want the precise number, it is 496. And here you are able to see there are 50% cases which are complete. The blue section represents the complete data. When you multiply the number of variables with that of the cases of missing, you will be able to see the total number of cells which are missing. In our data set, you have 723 records which are missing. I repeat, you have 723 blank cells. And the third pie chart is giving you the distribution of the missing values at the level of values. Let me now proceed to show you the variable summary. SPSS displays 3 variables: household income, years at current address, and marital status. These are the 3 problematic variables that are present in our data set. I say they are problematic because of the percentage of missing cases. Please have a look at the percentage of missing cases: 18%, 15%, and 12% respectively. So since the threshold of 10% has been specified, SPSS is highlighting all those problematic variables with a high percentage of missing cases. If you want the exact number of missing cases, you can see 179, 150, and 115 respectively. You can also obtain the valid cases, which are the non-missing cases. You have the mean and the standard deviation for the scale variables which are reported. Now, let me proceed to what is called as missing value patterns. I repeat, this chart is called as missing value pattern. This is a very, very important chart. As per my understanding, there is no other software which gives you what is called as the missing value patterns. What are you seeing here? In the x-axis, you see the different variables like age, tenure, gender, so on and so forth. And the y-axis, you are able to see the patterns. You can see here, there is one pattern wherein you are able to see only white spaces, which means that this is a pattern for non-missing cases. Please have a look at the legend here. The white space indicates non-missing. The red space indicates missing. I'd like to draw your attention to pattern number 43. My apologies. Let me say this again. Pattern number 43. You can see a lot of red color bricks here. You can see a brick against gender, marital status, address, and income, which means you have a lot of customers who have hidden or refused to give you information about their gender, marital status, address, and income. This represents one particular pattern. If I go to the pattern above this, that is pattern number 42, you can see here there are quite a few customers who have not given you information about their marital status, address, and income. I see a lot of red color cells for the variable income, which means that income is a variable which has a lot of missing values. Similarly, I see a lot of red color bricks for address, which means that there are a lot of customers who have refused to give you information about address, and there are multiple patterns in which the variable address is present. So you can have one pattern of missing values for variables like marital status, address, and income. There may be another pattern of missing cases wherein people have not given you information about their address, marital status, number of years with the current employer, and retirement. So this gives us a high level perspective about the combination of variables which have missing values. For this kind of a noisy data, it is not appropriate for us to use first level techniques like replacing the missing values with mean or median or mode. Let me scroll down and show you the graph below the patterns chart. You can see here, this is a simple bar chart. In the x-axis, we have the missing value pattern, and the y-axis, you have the percentage of cases which are missing. The first pattern has approximately 55% missing cases. Pattern number 28 again is quite dangerous because it has around 12% missing cases. Pattern number 19 has approximately 10% missing cases. The subsequent patterns, that is pattern number 12, 9, 5, 36, 3, 38, 2, have missing cases, but they are not on the higher side. When you have such a noisy data, it becomes very, very difficult to obtain robust estimates. How do we deal with this problem? In the next section, I will be introducing to my audience a very interesting technique, which is called as MCMC algorithm in combination with Bayesian inference to impute the missing values. Let me go back to the data set. This is the data set. Here, in this section, I will be demonstrating how you can obtain robust estimates for this noisy data. Let me go to the Analyze menu bar. I will now select multiple imputation. I've got two options. The first is Analyze patterns, and the second one is Impute missing data values. I've already shown you how Analyze patterns work. Now I'm going to show you how Impute missing data values works. Let me go ahead and select this. This will produce a new dialog box, which is called as Impute missing data values. As you can see here, all the variables are present. Let me go ahead and select all the variables and push this into the variables in model. I don't need level of education, so let me remove this. Let me draw your attention to imputation. The default option is 5. What does this 5 mean? It means that SPSS will give you 5 different imputations. It may impute the average, it may impute the blank cases with 5 separate values. The choice is yours. It depends upon the user as to which choice does he select. You can increase this to 10 imputations. It is entirely your control. Create a new data set. Yes, I would like to create a new data set, which is called as new. Please observe, this is telco underscore missing pre-imputation. The new data set which SPSS will create will be called as new. Now, let me proceed to method. Here, you have a lot of interesting options. What are some of the things that we can go ahead and do? The very first imputation method is the automatic method. You can see here, this option is the default option that is present in SPSS. This option automatically chooses an imputation method based on the reading of your data. I like to draw your attention to the custom method. As you can see here, there are two options that are presented before you. The first is the fully conditional specification, and it says MCMC. This is a good method, fully conditional specification or MCMC method. For those of you who are very, very new to MCMC method, MCMC stands for Markov Chain Monte Carlo simulation. Now, you may have this question, when do I use the MCMC method? The answer is very, very simple. When you check the distribution in the pattern of missing values, if the distribution in the pattern of the missing values is arbitrary, then it is better to go for MCMC algorithm. Now, you may ask me, how does the MCMC algorithm work in SPSS? At a very high level, please remember, MCMC algorithm works in 5 steps. The first step is initialization. Second step is model specification. The third step is iterative sampling. The fourth step is convergence check. The fifth step is imputation and inference. If you want a detailed description of each of these steps, please have a look at the description box of this video. I said there are 5 steps. The first stage is initialization. As the name itself suggests, what happens in this step is the algorithm starts with an initial guess for the missing values. The initial guess can be made using simple imputation methods like mean, median, or even randomly selecting observed values from the dataset. So the popular choices are mean or median here. The second step is very, very important, wherein the model specification happens. As the name itself suggests, we need to specify the appropriate model. Here, we define a statistical model that represents the relationship between the variables in the dataset. This model typically includes prior distributions for the parameters and a likelihood function that describes the observed data. If the variable that we want to impute is scale, typically linear regression is used. On the other hand, if the variable that we want to impute is categorical, logistic regression is used. The third step is what is called as iterative sampling. The word iterative means repetitions. There are multiple repetitions of sampling that takes place. This is a very interesting step. Here in the iterative sampling stage, we use the MCMC algorithm to generate a sequence of samples from the posterior distribution of the model parameters and missing values. Some of the common MCMC methods that are used include what is called as the Metropolis Hastings algorithm and the Gibbs sampler. SPSS typically uses Gibbs sampling method. These methods iteratively update the missing values and parameters by drawing from their conditional distributions. Let's now proceed to step number 4, wherein we are doing what is called as convergence check. In this stage, we monitor the convergence of the MCMC algorithm to ensure that the samples are representative of the true posterior distribution. This can be done by checking plots. There is a plot which is called as a trace plot or autocorrelation plot and other diagnostic metrics. Once convergence is achieved, the sampled values are considered to be drawn from the target distribution. In the fifth and the last stage, what happens is imputation and inference. Here, we use the samples that have been obtained from the MCMC algorithm. These are samples which have been generated in the earlier stage. We use them to impute the missing values. How do we do this? This can be done by averaging the samples or selecting the most likely values. The imputed data set can then be used for further analysis. So once you impute all these blank entries that you see, you can carry out high-end analysis like regression or time series analysis, or for that matter, decision tree or random forest. Now, why should we impute with MCMC algorithm? Because using the MCMC algorithm ensures that the uncertainty in the imputed values is appropriately accounted for in the subsequent inferences. So this is how, using the 5 stages of initialization, model specification, iterative sampling, convergence check, and imputation and inference, MCMC algorithm can be used to provide robust estimates. To summarize, by following the above 5 steps, the MCMC algorithm provides a robust and a very flexible approach to impute missing values. Remember, we are leveraging the power of the Bayesian inference to account for uncertainty and incorporate prior knowledge. While popularly we use the MCMC algorithm, we can always experiment with what is called as the monotone approach. When do we use the monotone approach? Typically, the monotone method is used, it is appropriate when the data has a monotonous pattern of missing values. The order in which you have specified the variables matters when you use this particular method. If you want to additionally specify two-way interaction among the categorical variables, you can go ahead and use the two-way interaction among categorical predictors. I'll remove this because that is beyond the scope of this particular video. Please have a look at the model type for scale variables, which is what I was describing earlier. The model that will be used for scale variable is linear regression. You can also use another method which is called as PMM, or predictive mean matching. Once you've made these selections, if you are interested, we can go ahead and specify the constraints. Remember, this is just an algorithm. It does not have human intelligence. SPSS may impute minus 10,000 for salary. However, we know that minus 10,000 is not a good value. Salary cannot be negative. Age of a person cannot be negative. This is where specifying certain basic rules will help the algorithm converge to the optimal solution better. Under the convergence, under the constraint section, the first part is scan of the data for variable summary. Let me go ahead and hit the scan data. You can see here the percentage of missing cases for each variable, what is the minimum and the maximum. If you are interested, you can copy and paste the minimum value and the maximum value for each of the variable. Please observe, the first section is the variable summary, and in the second section, you'll be defining the constraints. You can obtain the minimum value, which is 1 for tenure, and the maximum value is 72, in which case the algorithm will try to find the optimal solution within this range. It will not look beyond 1 or 72. If you want rounding off to the first or the second decimal, that is also possible. Now, a word of caution here. If you have a large data set and you specify too many constraints and too many parameters, the algorithm will take a long time. So it is better that we take a small data set, experiment it initially, and then we can extrapolate the logic for a larger data set. Let me go to the output section. Here you can see there is what is called as display. The first thing is imputation model. The second one is descriptive statistics for variables with imputed values. Let me go ahead and hit the OK button. You can see here the algorithm is taking some time. The algorithm has finished with the imputation. This is the output of multiple imputation. These are just summary information that SPSS displays. You can have a look at imputation model. SPSS says for the variable months with service, the model that it has used is linear regression. It will be using the linear regression to calculate the predicted value. The effects that it has used or the independent variables are displayed here. The total number of missing values that are present for the variable months with service is 32. The imputed value is 160. Typically, people ask me if there are only 32 values which are missing, how can SPSS come up with 160 imputations? Remember, SPSS gives you choices. There are 5 best choices or optimal choices that SPSS gives you. So 32 into 5 would be 160. The same principle works for the rest of the variables. SPSS displays which algorithm it has used, the number of missing values in each column, and the imputed values. 25 into 5 options, 5 choices, therefore 125. You can see the descriptive statistics. It is split into 3 parts. The summary statistics like sample size, mean, standard deviation, minimum, and maximum for the original data is given. Similarly, the imputed values, that is first 5 imputations, also generate the summary statistics. You can see what is the distribution of some of the statistics after imputation. So you can see SPSS mentions complete data after imputation. It is describing all the summary statistics. Right. But where are the imputed values? If you remember, we had created a new data set which is called as new. So please have a look at this. This is our new data set. SPSS has generated a data set which is called as new. You can see here imputation 0, which means that this is our original data set, and there are quite a few blank cases. Where is the imputation? Have a look at the top right-hand side. This is the original data. I have to click on the drop-down menu. Here, I can specify the first set of imputations. You can see here, income, which earlier had blank cases. Let me show this to you again. Let me go to original data. You can see here, there are quite a few blank cases for every variable, but please focus on the variable income. Original data, this is the first imputation. SPSS says that the average income that it has predicted is 183. Like this, you can also obtain the second imputation, which is 157. It has decreased. The third imputation would be 124. SPSS has further predicted a lower value. It has suddenly jumped to 205, and the fifth one is 266. You can see that SPSS has highlighted all the blank cases. Let me draw your attention to the variable employee. The predicted value for the number of years that an employee spends with the current employer for this record is -4, which is definitely wrong, because an employee cannot spend a negative number of years. So this cannot be negative. Similarly, for this customer, the predicted number of years is -3, which again indicates that this is a wrong number. All these mistakes can be avoided by defining the constraints, which I had not done. Maybe as an assignment, we can try this in the next video. With this, I have come to the end of today's session. In today's session, we have seen what is MCMC algorithm, and we have seen the working principle of MCMC algorithm. I thank you very much for watching this particular video. I request you to subscribe to my channel, also like and share my videos. Thank you very much once again. Have a great day ahead.